Hello, I'm Andy Briggs, and welcome to the amazing Astronomical Alphabet, a weekly programme in which my Astro Radio co-presenter Daz and I will be talking about anything astronomy related which begins with the week's letter of the alphabet. We'll each choose some things to talk about which are in some way related to the universe, but neither of us will know what the other has chosen. We will then reveal facts about them which are weird, strange, bizarre, or simply interesting. Well, welcome, dear listeners, to the amazing Astronomical Alphabet with me, Andy, and my esteemed co-presenter, Daz, who is sitting by my side, virtually, across 900 miles. How are you, Daz?
Oh, we're shaking hands. Oh, we're fine. The weather's turned for the worse. We've had our summer, which was 1 week, and then we've had about 4 days of Indian summer, but now we're back to dull clouds.
Yeah, you had some quite hot temperatures in the UK, didn't you? You had about 30
yeah,
or something,
on and
you?
off. It was just again, we were a few days, but then of course then it suddenly drops, and we're all back into the big coats, the winter coats.
Oh dear, what a shame. Yeah. Summer's dying song, eh?
Yeah, well, I keep getting my my lightning warnings, but yesterday's were in the Netherlands. You know, there's thunder near you. I thought
it's a bit
Catalonia, but they're getting better, I suppose. I think I'm going to have to change that app for a while.
I think you are. Yeah. Well, here it's been, it's beginning to cool down. We're down to about 27 now. And today is grey with quite a strong, cool wind. So it's, after it's nice to stand outside and let the wind wash over you, as it were. So there we are.
Make sure you keep some of that temperature, because I'll be downing the Canary Islands for in a couple of weeks' time.
Oh yes, of course you will. Yeah, that's right. Oh, well, you should be all right there, because it's a lot further south. I mean, it's just you're just off the coast of Africa, aren't you? So so you should be all right there. Excellent. Well, dear listeners, this week we are tackling the unfathomable depths of the letter N in our great voyage through the astronomical alphabet. And thank you so much for tuning in. And we'll make a start with the letter N. Daz, I believe, is you. And we'll make a start with the letter N. Daz, I believe, it's your turn to start first this week. So off you jolly well go.
Is.
As Jimmy Young would say.
Yes, off we jolly well go. What's the recipe today, Jim? Right. What we will do is we will start with N is for near Earth objects. N is for near Earth objects.
Very good.
Carry on, please. This can encompass a lot of things, but what I'll do is I'll give you a general description, and then we'll go through some of the items. Hopefully it won't be too long. If I get boring, just drag me up with a hook or something.
Okay.
A near Earth, also a solar system body whose orbit brings it into proximity with Earth. By convention, a solar system body is a near Earth object if its close approach to the sun, perihelion, is less than 3.3 astronomical units. And as we know, an astronomical unit is a single astronomical unit. If a near Earth object crosses the Earth's and the object is larger than 140 meters, which is 460 foot across, it is considered a potentially hazardous object, a PHO. The best known PHOs are asteroids, but a small fraction are comets. There are over 26,000 known near-Earth asteroids, over 100 short period near-Earth comets, and a number of solar orbiting meteoroids were large enough to be tracked in space. But that collisions in the past have had a significant role in shaping the geology and the biological history of the Earth. Near-Earth objects have generated increased interest since the 1980s because of greater awareness of this potential danger. Asteroids as small as 20 meters, which is 66 feet in diameter, can cause significant damage to the local environment and human populations.
Right.
Larger asteroids penetrate the atmosphere to the surface of the Earth, producing craters if they impact a continent or tsunamis. If they impact a continent or tsunamis, if they impact the sea. Asteroid impact avoidance by detection is possible in principle, and methods of mitigation are being researched. Since 1988, the United States and the European Union and other nations are scanning the skies for near-Earth objects in an effort called Space Guard. The initial US Congress mandate to NASA to catalog at least 90% of near-Earth objects that are at least 1 kilometer, which is 3,000, to cause a global catastrophe was met in 2011. In later years, the survey effort was expanded to include smaller objects, which have the potential for large-scale, though not global, damage. There are two scales that they measure them by. Hazardness, is that a word?
Hazardity.
The Torino scale and the more complex Palermo scale.
I've heard of the Remo scale. Yeah.
It's they rate the risk presented by identity of it impacting the Earth, and on how severe the consequences of such an impact would be. Some near-Earth objects have had temporarily positive Torino and Palermo scale ratings after their discovery. But as of March 2018, that shows how old this calculations based on longer observation arcs have led to all cases to a reduction of the rating to 0 or below.
Right.
So that's what they're telling us.
Yeah, well, yeah, they would, wouldn't they?
What they're like.
Yeah, I know what they're like.
So as I mentioned, we've got the near-Earth objects can be asteroids. Now they come in 4 flavors, and it's all based on their orbits and how close they get to, in whether or not they cross the Earth's orbit.
Oh yeah.
So you've got to cross the Earth's orbit.
Oh yeah.
So you've got Apollo asteroids, which a lot are considered potential hazardous objects, and a lot of these tend to. If you look at a diagram, a 2D diagram of the solar system, you'll see the sun, then you'll see the planets all spiraling out, and these objects are in a circle, but they're moved slightly to the right or left of the sun. But we know this is a 2-dimensional diagram.
Sure.
So they cross the Earth's orbit, which makes them basically potential objects that we can hit. And we've got, if you remember, I think it was last December, we had, now this is a hard one. It's 320 Phaethon asteroids.
Yes, I remember.
That passed us. Comets give us meteoroid showers, but Phaethon does the same. It gives us the Geminids,
right?
The meteor showers. But it was thought that this was to be a potential hazardous object for 2029, and that there was a possibility that it could hit Earth. But after its passing and more calculation, this has been moved back further. I think it's another 30 or 40 years.
Praise be.
It could become everything. But also, as I said, with these orbits, because of they some of them are on an inclination compared to the plane of the and the way all the orbits are elliptical and all that, these asteroids can move between their categories. The next category is Amor asteroids. These are asteroids that orbit out to Mars, as far as Mars,
right.
And do include the asteroid Mars,
right.
And do include the asteroid belt objects as well.
Sure.
But they come close to Earth's orbit sometimes. Then you've got Atens asteroids, which are again potentially hazardous objects, because smaller. This is a smaller, again potentially hazardous objects, because smaller. This is a smaller orbit inside Earth's orbit. But they do come out as far, because again they're elliptical. They can come out, sure. And they can cross the Earth's orbit.
Right.
Again, making them
makes them dangerous.
Hazardous.
Yeah.
And then you've got a subgroup of Atens which are called Atires, and these basically are inside Earth's orbit, but they don't come out far enough to cross the actual orbit of the Earth. But they do come out quite close. Of course, some of these asteroids we visit, Ryugu, which was sampled by Hayabusa 2, the Japanese probe, and it's returned its samples. And we had Bennu, which Osiris Rex has the probe has been to, and that's taken samples.
That's right.
And those samples will be back in 2023, basically piles of rubble.
Yeah, I was going to say, because if you remember when Osiris Rex tried to sample Bennu, it actually got a lot more than it bargained for.
That's right, because the actual collection bucket, instead of just touching the surface, because what the plan was to do, they called it a tag on to the surface. It would activate some nitrogen cylinders, which would push air onto the surface, and it would kick up the dust, and all the stuff would fall into the bucket. But when they did the tag, and they practice this a lot of times with actually tagging it, actually the head of its surface. They already knew that it wasn't a solid object. Because they'd scanned it with radar, and they decided that the inner part of it, which they thought was going to be absolutely solid, was honeycombed, and they think this thought was going to be absolutely solid, was honeycombed, and they think this could be due to possible water ice that's evaporated away, or things. But it all seems to be a big pile of rubble, and of course, because it spins, some of these little rocks float off, but then they tend to float back down again.
That's right.
Some of these little rocks float off, but then they tend to float back down
again. That's right. That's right.
So it was a fascinating thing, but that's coming back in 2023. Ryugu samples have been already returned, and the Japanese have been having a look at them, and again they found that the rocks that they're trying to examine are very, very crumbly and porous. So if these asteroids are like that, then it'll be interesting. Well, it would be interesting to us to see what if happened one did enter our atmosphere. But we don't want to test that, really.
No, we don't. We don't want to test it. To compare Ryugu and Bennu, that will throw up a lot of useful information, I'm sure.
Of course. And of course, then I did mention comets as well.
Oh, yes.
Well, of course, you've got your short period comets, you've got your long-term comets. And of course, we visited a comet. It was, here we go. I'll try to pronounce this. Comet 67P, which was Chernimov Gerasimenko.
Just call it so. Everybody just calls it Comet 67P. It's a lot easier. Everybody knows what you mean.
I was trying to be clever, and I didn't do too bad. And that was visited by the Rosetta probe and landing. It did actually land on there, but it was caught in a gully, and unfortunately,
it bounced. It bounced 3 times, I think. I think the first time it bounced, it was in the air for over 2.5 hours because of the low gravity. But the poor thing was, but it still carried out about 72 hours before its battery.
It gets sent back some data and all that.
Yeah, so they got some really useful things, but not the full data set they were hoping for. And we have to stress, though, this was a European mission, and it was the first time that anybody had put anything on a comet, including, of course, Rosetta itself, because when it came to the end of its mission, including, of course, Rosetta itself, because when it came to the end of its mission, it soft landed on the comet, and there it remains to this day.
To this day, and of course, there are plans to visit more comets in the future. And of course, I did mention that these comets and these comets and asteroids do give us meteor showers.
Absolutely.
Well, there's been a survey which has been done over the last few years where they've studied what we call irregular, and they've looked at these and studying them, their trajectory and stuff like that, and they've actually found several more meteor showers, but they're not so intense. But they're the indications that there are comets that have visited us, and they may return but it's over 1,000.
It's from the Oort cloud.
Exactly, very, very long period. And so, yes, and of course, again, these could eventually become, when they come back in, because we know nothing about them, they could become potentially hazardous objects. But also, there are man-made near-Earth objects, and one of them was J002E3.
Oh yeah,
and it was noted, and they thought this is going to be a near-Earth object, and it could potentially be a hazardous object. But then they thought it was very to be a hazardous object. But then they thought it was very strange. And what they did is they started speculating, and they thought, and then somebody come up with the idea, well, hang about, could it be man-made? And what they did is where they thought, well, and it was put forward that it couldn't. What they did is where they thought, well, and it was put forward that it could be part of the Apollo spacecrafts. And what it was is they said, well, how can we find out? So what they did, so we know in orbit there's a failed booster system running up there that's been out there about the same amount of time. Let's study that. So using spectrographic means, they looked at the booster that was orbiting the Earth, and they analyzed it. And of course, it had signatures of titanium. Of course, it had signatures of titanium oxide that was used in the paint, which was used on the Apollo missions. So when they thought, right, let's have a look back and all that, and they did a spectrographic investigation of this object. And what it turns out that it's actually the third stage of it was supposed to have been put into orbit around the moon. But because due to an extended burn and some exhaustion of gas, fuel and things like that, it didn't make it, and it actually went into an elongated orbit, and it's been around the sun. Now, when it comes to us, and I think it's the Earth several times before again it will then shoot off back the way it came. So we've got that to look forward. There was also 2018 AV2. Now, this is the one I'm fascinated with, and it is believed to be Snoopy, which is Apollo 10's.
Really?
They use the practice.
The famous Snoopy. Wow.
Yeah, the famous Snoopy. And of course, that's been off around the sun as well. Apollo 10, it's basically, that was a practice mission where they used a module, and they basically orbited the moon, but they didn't. And then they just Apollo 10. Yes, they did. They tried. They went down so far, but they weren't. In fact, because they couldn't trust the astronauts not to land on the moon because they would be so close. Yeah. They only gave it so much fuel. So
sneaky.
They just slung it off. And of course, that's at first they thought it was an asteroid, but again, they've now discovered that it could be.
If I remember rightly, wasn't John Young the commander of Apollo 10? Because he went on to be a famous shuttle astronaut as commander of the space shuttle.
Hang on, wait, no, there wasn't the compare. Oh no, I was just thinking of CERN, but no, it wasn't. And of course, there are talks of maybe when it gets a little bit closer, of maybe sending a mission to at least photograph it, maybe even retrieve it, and that would be fascinating if they could retrieve it.
Wouldn't it? How are you gonna do it?
Yeah, how are you going to bring it back? Because we've got nothing to bring it back now and all that. So, but yeah, it would be absolutely fascinating. Of course, we've got Elon Musk's Tesla that will be coming back in a few years, which will be coming Musk's Tesla. That will be coming back in a few years, which will become
Starman's Roadster. Yeah.
His Roadster, that will be coming back at some time, and that could become a potential. I think it's about 1 million years. They reckon it's going to crash into the Earth if it's possibly going to happen. And it might into the Earth if it's possibly going to happen.
And it might even crash into Mars before then, because it does cross the orbit of Mars. Who knows?
That's right.
By the way, I've just checked, and it was John Young.
It was Mr. Young,
along with Stafford and Cernan, with the other two Apollo 10 astronauts. And anyway, it's not important. I just thought I'd mention it.
But of course, we still get the odd rogue thing that comes in from outside the solar system, i.e. Oumuamua.
Yes, absolutely.
Which was considered to be from interstellar, and was even considered alien technology, but we won't go into that.
No, I think the jury will forever be out on that one.
Yeah, it was spotted really late, and basically it already passed us by the time we actually saw it.
But there will be others. There will be others.
There will be
in
others.
fact, there was an interstellar comet, wasn't there? About a year ago.
Yeah.
That was
so basically, that's my little rundown. I could go on. I've got about 25 pages here, all about near-Earth asteroids, with some technical stuff and things like that. But we'll leave it there. But yes, that is N for near-Earth objects.
Thank you for that. That's very worth saying that one of these near-Earth objects will hit the Earth and cause a major cataclysm one day, because it's happened throughout geological time. So, we're not immune from it. We had a near miss in 2011, was it? I think, with the Chelyabinsk event, where a piece of rock about the size of a double-decker bus exploded over the Russian city of Chelyabinsk. Yeah. Over 1,000 people were injured, mainly through flying glass, when the shockwave destroyed windows of buildings. And that was destroyed windows of buildings. And that was a very near miss. And if that had actually hit the city, there would have been a huge loss of life. And they actually found the major chunk of it in a lake next to the city that was frozen over. And there was this big hole next to the city that was frozen over. And there was this big hole in the lake. Yeah. And they located where it was on the floor of the lake, and they tried to raise it up, but unfortunately it was so fractious, so fragile, that it broke in two when they tried to lift it. Yeah. But they did eventually manage to get both chunks, I think. Eventually managed to get both chunks, I think. So we're going to be hit like this in the future. Yeah. And we need to be prepared, which is why the Space Guard and everybody who is looking out for us, trying to identify these objects and where they're going and what they're going to do and when, is an extremely valuable yet chronically underfunded organization. So there we are.
Yeah, all right then. Sorry, guys. There are plans to send out missions to see if they can nudge these things away and things like that. Yes, absolutely. It goes to as much as to paint one side of the asteroid white, so that the sun
pushes it away. Yes,
push it away and things like that. There's lots of ideas, but yes, as
you
said,
it's a disaster that will happen again. I don't want to worry anybody, but it's a very difficult. It's going to happen. It could happen at any time. And it may happen tomorrow. It may happen in 1,000 years. But statistically, the Earth gets hit by what we would call a sizable life-threatening object about once a century. The last time really being the Tunguska. The jury is still out a bit, I think, on whether it was an asteroid or a comet nucleus. But, that was a devastating impact in Siberia in 1908. And if that had hit a major city, again, there would have been...
But again, they consider that to be an airburst as well, don't they?
Yes, that's right. Because there were no fragments.
To be an airburst as well, don't they?
Yes, that's right. Because there were no fragments ever found.
Yeah. But I wouldn't worry about an asteroid coming to us, because Bruce Willis is still alive.
That's right.
And when he dies, we'll cryogenically freeze him, and then we'll wake him up if we get a bit of a problem.
By the look of him recently, I think he already is cryogenically frozen. So N is for Nemesis.
Right.
Now, Nemesis, to go back a bit, was first put forward as an idea in 1984. All indicative of how much astronomy has moved on, even since 1984, which to me still seems like yesterday. I don't know about you, Daz, but it's nearly 40 years ago.
Doesn't seem that long ago. I was banging my head against the wall to get out of school.
No, that's right, absolutely. Yeah, and you were 27 at the time. So exactly. Most stars like the Sun are born in pairs or triplets or even larger configurations. And they said that because of this, the Sun was probably born with a twin that orbits away from the Sun about 1.5 largely, because it's on a highly elliptical orbit around the Sun. It comes closer to the solar system and passes through the Oort cloud, and this nudges all the many objects out of the Oort cloud towards the inner solar system, where they impact with the Earth and cause the periodic mass extinctions. That it was a perfectly reasonable scientific theory, but it suffered from one thing that which was not known at the time. In fact, what they thought Nemesis is a brown dwarf star, probably a brown or red, even a red dwarf star, probably a brown or red, even a red dwarf star. But they erred on the side of it being a brown dwarf. Now, if anybody doesn't know, a brown dwarf is somewhere between a star and a planet. It's usually, up to, I think the upper limit that they found so far is about 18 times the size of Jupiter. And instead of the star using hydrogen fusion to generate its energy, it fuses deuterium. It fuses deuterium, which fuses at a much, much lower temperature. So these are often referred to as failed stars because they haven't ignited hydrogen fusion, but they undergo at their cores deuterium fusion, which, as I said, happens under infusion, which, as I said, happens under much cooler circumstances. So they do radiate energy. They are basically infrared objects because they don't radiate that much light because of the cooler temperature, but we can see them at infrared wavelengths. So this was the idea that the Sun was born with as a brown dwarf star. Now, in those days, back in the 80s, the prevailing astronomical opinion was that for every one star, there is one brown dwarf. In terms of numbers, that doesn't say every star has a companion brown dwarf, but in terms of numbers, it's a one-to-one relationship. There are as many brown dwarf stars, not true. The current figure is that for every brown dwarf, there are at least 6 stars. So brown dwarfs are not as plentiful as we once thought, not as abundant as we once thought. This idea then has been discredited, really. The fact that perhaps the Sun was born in a binary pair, but astronomers have now discovered that most Sun-like stars are born alone. They don't have companions, whether it's a brown dwarf or a red dwarf or any other type of star, or even another star like themselves. Sun-like stars are born another star like themselves. Sun-like stars are born alone. So the idea that the Sun did have a companion, although it can't be ruled out, is not very likely. And if you think about this, the periodic mass extinctions of species on our planet cannot be due to this star, incidentally, that they called Nemesis. The Sun's so-called companion star was dubbed Nemesis, because if you think about it, the 2 stars would have separated over 4 billion years ago after they were born, or we don't know of them when life first appeared on the Earth. So the first mass extinctions didn't occur for a couple of billion years after life appeared on the Earth. So it's unlikely that Nemesis would have been responsible for these mass extinctions. And the whole idea now, perfectly valid scientific theory, so there was nothing wrong with it, but it's fallen out of favor because we now know that brown dwarfs are nowhere near as abundant as we thought, and the fact that Sun-like stars tend not to have companions. So there you are. So that's Nemesis, the assumed evil twin of our sun, the evil twin brother, if you like. But that didn't stop the idea catching on in the media, of course. And, as usual, people who really don't know much about the universe and can't be bothered to learn anything latched onto this. And, for a while, I remember back in the 80s and 90s, the amount of stuff that was out there about Nemesis and, when it was going to come into the inner solar system and it was going to, disrupt life on the Earth and plagues and floods and, all the rest of the disasters and, all the rest of the disaster scenario that you saw arising in films like 2012, when everybody got really, because of some presumed Mayan prediction that wasn't a prediction in the first place. And anyway, so but Nemesis has definitely fallen out of favor.
The Mayan calendar that ended, and they thought it would be the end of time, because they produced a couple of films about it and things like that. But the thing is, it did catch on.
It did.
It did. And my partner's daughter will kill me for saying this, but on the night of the date that it was supposed to finish, she woke up during the night screaming her head off, stood at the window, and she swore blind that the world was ending. It was one of those things. I won't let her forget it. But yes, it's because they have found stars in the Milky Way, which they think are because their composition is the same. It just means that they were born in the same cloud.
Yes, in the same cloud of molecular hydrogen. Yes,
molecular hydrogen. So, because they've got virtually exactly the same makeups and things like that. But of course, they would have formed in some sort of cluster, probably an open cluster. But they have found one or two stars which could be candidates.
Yes, they had very similar composition to the sun. But the ultimate nail in the coffin of Nemesis, of course, is that we haven't seen it in infrared telescopes.
No,
there's no heat in the solar system that we've ever seen, so it's not there. End of story.
You'll be able to tell if it's moving because of whether or not it's red shifted or blue shifted.
So no, it's not there. It was a lovely idea. And I never thought that Nemesis was a good name for it, because Nemesis has all sorts of bad connotations. Bad
connotations.
But I suppose, if it were responsible, if it had been responsible for the mass extinctions that happened on Earth. And another thing, of course, was that the people who were putting forward this idea that Nemesis was responsible for successive mass life extinctions events. They said that it happened every 26 million years, and it had to be something like a star on a regular orbit that nudged the Oort cloud every 26 million years. But then, of course, it turns out the mass extinctions don't happen every 26 million years. There's no regular timetable to them. There's no fixed time between them. So it's unlikely. So there you are. So that's the whole Nemesis thing done and dusted.
Okay,
over to you, Daz.
Fascinating. That was the last show, but the show before, we were talking about exploding rockets in Russia.
Yes, we were.
And I mentioned a rocket that, when it exploded, was considered to be one of the biggest man-made explosions, non-nuclear, because you did ask that at the time, and it's still in the top 10 list. Now that rocket, so N is for N1. That is the
famous Soviet N1.
Yeah, the N1 rocket, or the carrier rocket, as they called it. Now, basically, there were some of them were mock-ups, and some of them never flew. They were scrapped before when the whole system was cancelled. But basically, it was a heavy superlift launch vehicle intended to deliver payloads beyond low Earth orbit. The N1 was the Soviet counterpart 5, and was intended to enable crew travel to Earth's moon and beyond, with studies beginning as early as 1959. So they had ambitions quite early on.
Yeah, sounds like
its first stage remains one of the most powerful rocket stages ever built. And as I said, there are powerful rocket stages ever built. And as I said, their idea was just strap more rockets to it.
Yeah. What do we need? More rockets. When do we want them? Now.
Yeah, more rockets. Yeah, strap them on. First ever built. It's only been surpassed now by the SpaceX Super Heavy first ever built. It's only been surpassed now by the SpaceX Super Heavy first stage, and that was in 2021, but it hasn't actually taken off.
No.
However, all of the 4 flown, there was only 4. N1 block, which is the first stages.
Yeah.
Because they call them blocks, not stages. N1 block A, first stages failed because of lack of static testing firings meant that plumbing issues and other adverse characteristics with the large cluster of 30 engine oxidizer feeder system were not revealed earlier.
Hang on, are you saying they threw that thing into space without doing any static fire tests?
Very, very few. There is a whole story behind it. I'm not going to go into it this time. I'm just going to talk about. If you wish to know more, then listen to my other show, Astronomy with Daz, in the next couple of weeks, because I've actually telling the story of the N1 rockets.
And when can we hear your program, Astronomy with Daz?
They're usually scheduled to begin on Sunday evenings, and then they're repeated throughout the week. They're usually scheduled to begin on Sunday evenings, and then they're repeated throughout the week at various times. Just look for the schedule.
Yeah, check the website for details. And I have to, I mean, I know, he's sitting next to me virtually across 900 miles. But I have to say, do listen to Daz's program. But I have to say, do listen to Daz's program, because it's always really interesting and entertaining and educational. All that. Oh. No. I'll give. You can give me the $5 later. It's okay.
Yeah.
So Astronomy with Daz, another program here on Astro Radio that you might like to listen to.
Yeah, and
I will sit on the planet.
And altogether, I think there was something like on this whole thing. Like I said, there's 30 engines in the first stage. I'll just go through it, and then we'll have a quick chat later. The N1L3, which was the first one to their test to be launched, was designed to compete with the United person on the moon, using a similar lunar orbit rendezvous method.
Right.
The basic N1 launch vehicle had 3 stages, which would carry the L3 lunar payload into low Earth orbit with 2 cosmonauts. The L3 contained 1 stage for mid-course corrections, lunar orbit insertion, and the first part of the descent to the lunar surface. A single pilot LK lander spacecraft and 2 pilot Soyuz 7K LOK lunar orbital spacecraft for return to Earth. So that's what a chunk of it. N1L3 was underfunded and rushed, starting development in October 1965, almost 4 years after the Saturn V. The project was badly derailed by the death of its chief designer, Sergei Korolev, in 1967. Yeah. He was sort of considered the father.
He was the father of the Soviet space program, and what a guy! What an incredible engineer! But of course, in those days, having 30 engines on a rocket when previously what have been the maximum? 3, 4. Obviously, what have been the maximum? 3, 4. I'm very doubtful that anybody at that time would have had the technology to run and manage 30 engines.
Well, as you said, it had it was under they didn't do enough testing. It was under testing. No. Each of the 4 attempts to launch an N1 failed. The second attempt resulting in the vehicle crashing back to its launch pad shortly after liftoff and causing one of the largest artificial The M1 program was suspended in 1974 and officially cancelled in 1976. All details of the Soviet crewed lunar programs were kept secret until the Soviet Union was nearing collapse. So they thought.
Yeah.
Because I won't go into it, but the Americans were already onto them. They got spy satellites.
Of course, they knew what was going on. Yeah,
they managed it. Well, actually, no, it wasn't a spy satellite. Could have been, because it was. I think it was one of the. What was the name of the planes that Steve Austin got? The pilot got caught in. Steve Austin got the pilot got caught in.
Well,
the spy plane. Yeah, the spy plane.
Oh, the U-2.
I think it was one of those anyway, where they managed to catch some pictures of it. As I said, I could go into all the details as regards. It was. I said I could go into all the details as regards. It was basically it was N1 with the serial number 5L, which was the one that crashed back. It was the first night launch attempt. And as it just cleared the tower, I'll just quickly go through this. I won't do it.
Sure.
As it cleared the tower, there was a flash, and then parts were seen falling from the engine compartment. All the engines instantly shut down except engine 18, which tilted it by 45 degrees as it dropped back to
oh dear,
the actual pad. Debris was in the ensuing explosion. Debris was thrown across 10 kilometers, which is 6 miles from the center of the actual explosion. About half an hour later, the launch crews were permitted to leave the safety buildings, but once they got out, burned fuel still raining down from the sky.
Wow.
But the worst scenario had not happened, where the fuel had mixed with the LOX, and that would have made a very explosive gel.
Wow. I mean,
which would have been, but that had not occurred.
That's a.
And they said in the subsequent investigation, only 85% of the fuel on the rocket, that's the whole of the rocket, all through the stages. 85% of the fuel in the rocket throughout all the stages did not ignite.
Thank goodness.
You're only talking about 15%, which was mainly the first stage that exploded. It completely destroyed the launch platform, left a very big hole. Also, despite the devastation, most of the telemetry tapes were found intact, so they were able to work out what actually had happened. Those
black box manufacturers on the case there, then obviously
they certainly were, and it took
on the case there, then obviously
they certainly were, and it took many months to rebuild the launch pad, and so that also delayed the development of the N1 rockets. But yes, it was, as I said, it created one of the largest explosions in the world. So you imagine if the whole lot of that had gone up. In fact, it's
unimaginable
because it was a night launch. It was the actual explosion was visible 35 kilometers away, which is 22 miles in Leninsk. They actually saw it actually go off. As I said, if you want to know more about these amazing rockets, or not amazing rockets, really, then listen to my show. It's be coming up soon.
I'll be listening, obviously.
It'll be in the next week or two.
Okay, we'll look forward to that.
And so that was the Russians' answer to the Saturn 5 rockets.
So I wonder what their plan was for it, because if you've got a 30-engine rocket, you've got a massive lifting capability. So I don't know what the cargo capacity was of. I wonder how much cargo they could have carried on it and why, because that was complete overkill as far as getting to the moon was concerned. They didn't need that powerful a rocket.
Well, these rockets that they used were only small.
Right.
They're not huge rockets.
No,
and they
were
the set up rockets around, which surrounded 6 in the middle, which were gimbaled, so that they actually controlled the trajectory and the stabilization of it, of the actual rocket as it took off. So you have basically just 24 rockets just firing away. So you have basically just 24 rockets just firing away. And it was I think it was, if I remember right, it was a kerosene and LOX rockets, because one of the I'm giving away secrets here. And one of the main delays was a dispute over the rockets. A dispute over the rockets, which we may discuss a little bit later on.
Okay.
If we've got time, because it may come up again later.
But wasn't the M1 was a bit of a weird looking rocket as well, wasn't it?
Yeah, because it's I don't know how you describe it.
It's fat at the bottom,
it's very
at the top.
Yeah, the opposite of a brontosaurus.
Yeah, exactly. Exactly. Thank you, Anne.
Also, they for some unknown reason, every rocket was in a different color scheme. It was, well, I can't say a color scheme. It was gray or white, but different. Right. They changed where the white was.
Rocket looks like you can find pictures on the internet.
Yeah, go Google on there.
But I mean, basically, if you think of a cylinder that gets fatter at the bottom or towards the bottom, it was a really weird design. And not so long ago, how long ago now? Maybe 6 weeks ago, Elon Musk took a photo standing underneath the Falcon Super Heavy the night after they installed all 29 engines, which they did in a single night, which was an unbelievable feat. But he took a photo looking up from underneath at the Raptors, where you could where you could clearly see, the amount of fuel plumbing that you need to power 30 or 29 engines in this case, 29 engines. And Elon Musk said, but this is nothing. This is nothing. This is just the fuel plumbing. We've got to get the electrical, the data, the hydraulic connections in. He said, and in fact, this is the most difficult bit about building the whole rocket. He said, designing it was easy, but putting all the plumbing in for fuel, data, hydraulics and everything else, he said, is an absolute nightmare. But they're doing that now, or they have done it, because yesterday the Falcon Super Heavy rolled out to the launch site to begin its testing program. So it'll be undergoing pressure and cryogenic tests first, and then there will be a static fire of the 29 engines. And that will be amazing to watch, because nobody, apart from the Russians with the N1, has fired 29 engines under a rocket at the same time. So we've got that to look forward to, maybe sometime because that will be amazing. Yeah. All right. So thank you for that, Daz. That was the N1. An idea, I think, somewhat ahead of its time in terms of the design of launch vehicles.
Yeah. Like I said, if you want to know more about it, you can, like say, Google it or whatever.
Yeah. Listen to Daz.
Available. Or listen.
No,
I did consider making it a 2-hour show, but I thought that would just.
Is your program just about Russian rockets?
This one is just specifically about the N1.
Specifically about the N1, so that's going to be a good listen. Thank you, Daz. I should definitely tune in. Now, when I was talking about Nemesis earlier, I thought of another thing, and that is N is for Nibiru.
Oh yeah.
Yes, you remember Nibiru? Well, it's still around. Let me explain what this is. This was an idea that there is a planet out there at an unspecified distance from the Earth, is on a collision course with the Earth. Now, where did such an idea come from? This mysterious Planet X, that's another name for Nibiru that you may hear, Planet X. Where did this idea come from? Well, this idea was put forward in 1995 by a lady called Nancy Lieder, Lieder. And she founded a website called Zeta Talk. And on this website, she describes how she actually has had contact with aliens and is able to receive messages from these aliens, and they come from a star called Zeta Reticuli. And how does she receive these messages? Well, obviously not telepathically, because that would be silly. She receives them because that would be silly. She receives them, of course, from an implant that the aliens put in her brain. Now, to date, she has steadfastly refused to be scanned to demonstrate that she has an alien implant in her brain. I wonder why. So basically, she's nutty as a fruitcake. And she came up with the idea that the aliens had told her that there was this completely invisible planet that has never been detected by anything that was going to impact the solar system. And you would think that that would have been the end of the story. Everybody would have just laughed and carted her off to the funny farm. But unfortunately, that didn't happen, because she predicted that Nibiru, which is the size varies depending on which idiot you read, but it's, Earth size or larger, in May 2003. And when that didn't happen, she said, "Oh, implants playing up. Sorry, I was receiving Radio Luxembourg instead, or something." And she put back the date. And, and mainly in America, of course, latching on to this fact that Nibiru was going to hit the Earth. And not only was it going to hit the Earth, it was going to cause the Earth to flip over, turning the poles around and kill everybody on the planet. Okay, so, fun and games, basically. And loads of internet groups sprung up, around this, and it's definitely going to happen. And, I used to chat with a few of them on the net just for fun. And, it's like trying to talk to a block of stone, to be quite honest. But, there are lots of sort of doomsday groups on the internet that latched onto this. And somehow this idea of Nibiru hitting the Earth became attached to yet again the 2012 phenomenon and the Mayan prophecies, and they were all rolled into this. Well, it didn't happen in 2003, nor in 2007 when she said it was going to, not in 2010, 2012, no. Oh yes, it'll happen in 2012, no. Oh yes, it'll happen in 2012, because the Earth's going to end anyway because of that, Mayan prophecy. So that was not only that, but even objects like Comet Ison were brought in, as morons were saying, "Oh, well, it's not a planet like the Earth, it's a comet, and there it is, it's Comet Ison, that's going to hit the Earth." And of course, that failed too as well. Even the planet 9, which some astronomers think may actually exist out there in the solar system, even that has been roped into it now. But the name interpreting Babylonian and Sumerian mythology, and because of this, he says, "Oh yes, this planet appears in their mythologies. It's definitely going to be a coming apocalypse." And is he an historian? Is he, is he an archaeologist? Is he an anthropologist? No. Right, who played with a few numbers that he'd plucked out of the air from Babylonian and Sumerian mythology, and said, "Right, I've got it. It's going to hit the Earth on 23rd of September 2017. And that's definite, right?" Guess what? It didn't happen. And when it happened, didn't happen, guess what he did? He changed the date again, and it was meant to happen at the beginning of this year. The amazing thing about this, you've got a woman who thinks she's got alien brain implants. You've got a Christian numerologist who knows bugger all about astronomy or anything else, as far as I can make out, making these predictions. Instead of laughing at these people, countless people on the internet have swallowed this hook, line, and sinker And when you try and talk with them, as I said, I have, and I said, but astronomers, if that were coming towards the Earth, we'd be able to see it now. Towards the Earth, we'd be able to see it now, long before these dates that they're putting forward. And astronomers don't see anything. How do you explain that? Well, of course, astronomers, it's all part of the big NASA conspiracy, and there they go yet again down the rabbit hole into conspiracy theories and so on. So the amazing thing is that these ideas take hold, and instead of looking at the people and saying, the people who put these ideas forward and saying, are they astronomers? Are they scientists? Do they actually know what they're talking about? And then you find out one's got a brain implant as a Christian numerologist. Instead of saying these people are talking shit, they just, oh yeah, that must be true. That must be true. I believe it. So it's a human phenomenon that has got a neurological explanation for it. And I'm damned if I know what it is, but I'm sure some people are, just so willing to believe complete bollocks. And it amazes me how gullible people are. People just don't seem to have the mental machinery to indulge in any degree whatsoever of critical thinking. It was, as I said, a fairly respectable scientific theory that could have been true, but observations have demonstrated it's not. That's how science works. So we move on. Nibiru is a manifestation of some mass delusion, and it amazes me. You could write.
I remember all the fuss.
It amazes me. You could write.
I remember all the fuss at 2017. Made the papers
absolutely.
And everything, all kicked off again. And I spent most of my time trying to explain to people, please.
I know, me too, Daz, me too. But don't you think it's amazing that if you look at the number of hits the websites get, the day after it didn't happen, they didn't. The day after it didn't happen, they didn't drop.
No,
the people were still believing this stuff. Yeah. It's amazing. Anyway, that's Nibiru. There's no planet Nibiru. If there were, it would take thousands of years probably to come in from the outer solar system. So we wouldn't know about it. It's an idea put forward by a mad woman, and that's the end of it. And that's where it should end. But it won't. Okay.
Yes, Nibiru. Oh yeah. I'm sorry, but I had to giggle all the way through that. It was just it's these people do. It's like you say. It's just how people latch onto it, and the internet's got a lot to answer for. The internet is just so accessible. All this junk.
Yeah. Absolutely.
And as you said, unfortunately, people do tend to fall for it. I mean, these doomsday cults and stuff like that, they love
they do. And I've always said that you should have to demonstrate that you've got at least two brain cells to rub together before you're allowed to use the internet.
Oh, wait, I better sign off then.
Bye. That was Daz on Astro Radio. Daz has left the building. So,
with his one brain cell.
Yeah, with his one brain cell. So,
with his one brain cell.
Yeah, with his one brain cell. Yeah, slung over his shoulder,
and his tail between his legs.
Bye, Daz. Nice knowing you.
Right. Okay then. So
Over
thanks
to you,
for that, Andy. Yeah,
that's
thanks for that. That was interesting. It's comical, but unfortunately, as you said, too many people are.
Well, for us astronomers, Daz, it's just frustrating because you can't have rational conversations about the universe anywhere these days. It happened again today. I got called a tool of Satan on Facebook yesterday because I dared to suggest that the Earth goes around the.
She'll be telling us the Earth isn't flat.
Well, no, it's got bumpy bits. Definitely.
Bumpy bits, mountains.
Yeah.
Well, of course, when Nibiru hits us, then it will spin like a plate, won't it?
Yes, absolutely.
Flat, yeah. It'll be like tossing a coin.
Yeah, it'll be like those people putting the plates on poles, and nobody's ever seen the pole, though. That's my argument. Show us the pole. And put your money where your mouth is. Show us the pole.
Well, it's on the back of 3 elephants, isn't it? Something like that. Anyway,
turtles, mate.
So yes, we'll move on. We'll move on.
Turtles all the way down.
Right, I'm going to cheat a little bit here.
Oh, what again?
Yeah, again. Well, right, I'm going to cheat a little bit here.
Oh, what again?
Yeah, again. Well, it's all part of it, isn't it? And I'm going to say N is for NGC 1952. So NGCs, I mean, we could have pulled everything out there.
You see, you're getting like this with your NGCs. You're getting like my moons of Jupiter and Saturn.
Yeah, well, that's your mum.
With your NGCs, you're getting like my moons of Jupiter and Saturn.
Yeah, well, that's your mum's fault, isn't it?
It is. It's all my mum's fault. I blame my mum for it.
NGC 1952, also known as M1 or Taurus A, and best known as the Crab Nebula.
Hang on a minute. So, nebula. Okay, I'll grant you. I'll allow you.
As I said, I'm playing with it, but it's an NGC. So
yeah.
So is everything else in the universe. But the Crab Nebula is a supernova remnant, a pulsar wind nebula in the constellation of Taurus. The Commons, who observed the object in 1842 using a 36-inch, which is 91 centimeter telescope, and produced a drawing that looked somewhat like a crab. If anything, it looks more like a horseshoe crab, I would say. His drawing.
Yeah, I'd agree.
But go online and have a look. The nebula was in 1731, and it corresponds with a bright supernova recorded by Chinese astronomers in 1054. When it went off, it could even be seen in the daytime.
In daylight, yeah, amazing.
Yeah, the nebula was the first astronomical object identified that corresponds with a historical nice. At an apparent magnitude of 8.4, comparable with Saturn's moon Titan, it is not visible to the naked eye, but can be made out using binoculars under favorable conditions. The nebula lies in the Perseus arm of the Milky Way, at a distance of 2 kiloparsecs, which is 6,500 light years from Earth. It has a diameter of 3.4 parsecs, which is 11 light years, corresponding with an apparent diameter of some 7 arc minutes, and is expanding at a rate of about 1,000 arc minutes, and is expanding at a rate of about 1,500 kilometers per second, which is 930 miles per second. Yeah, or 5% or 0.5% of speed of light.
That's quite fast.
At the center of the nebula, lies the Crab pulsar, a neutron star, 28 to 30 kilometers, which is 17 to 19 miles across, with a spin rate of 30.2 times per second. So it's whizzing around a bit.
Yeah.
Which emits pulses of radiation from gamma rays and gamma ray energies above 30 keV. The nebula is generally the brightest persistent gamma ray source in the sky, with measured flux extending to above 10 TeV. The nebula's radiation allows deep. In the 1950s and 1960s, the sun's corona was mapped from observations of the Crab Nebula's radio waves passing through it.
Oh, really? I didn't know that.
Yeah, I didn't know that until I read this.
No.
And in 2003, the thickness of the atmosphere of Saturn's moon Titan was measured. So it's a useful little tool.
So there was an occultation of the nebula then.
Yeah,
by Titan. Wow, amazing.
It says so I'll move on. I won't go into too much detail. And basically, as I said, there's a pulsar at the center. It says pulsars are the sources of powerful electromagnetic regular pulses many times a second. They were a great mystery when discovered in 1967, and the team who identified the first one considered the possibility that it could be a signal from an advanced civilization. However, the discovery of a pulsating radio source in the center of the Crab Nebula was strong evidence that pulsars were formed by supernova explosions. They now understand to be rapidly rotating neutron stars whose powerful magnetic fields concentrates their radiation emissions. Concentrates their radiation emissions into narrow beams, and that's what we pick up.
Yeah, we talked about that before.
Yeah, the star that usually when these nova happened, the stars that actually go supernova are called progenitor stars. And there are two types of supernova. There's supernovae. You've got white dwarfs and massive stars. In the so-called Type 1a supernova, gas falling from a dead white dwarf raises its mass until it nears a critical level, the Chandrasekhar limit, resulting in a runaway nuclear fusion explosion obliterates the star in a Type 1b/c and a Type 2 supernova. The progenitor star is a massive star. Core runs out of fuel to power its nuclear fusion reactions and collapses in on itself, releasing gravitational potential energy in a form that blows away the star's outer layers. Type 1a supernova do not produce pulsars, so the pulsar in the Crab Nebula shows it must have formed in a core collapse supernova. I'll leave it there because it goes on with a bit technical stuff. So that is
just something that just occurred to me. I don't know whether you can answer this. Did you say that the pulsar's rotating at 10 times a second? Did you say that the pulsar's rotating at 10 times a second?
Let me just go check.
I think if I remember rightly, it is 10 times a second or thereabouts. Because the thing that occurred to me,
I did say, where was it?
Sorry. Where
was it?
Sorry. I'm pretty sure it was 10 times a second.
Oh, it says here, got a spin rate of 30.2 times per second.
Oh, faster than I thought. Sorry. 32 times per second.
Because I also think it was one of the pulsars discovered by Dame Jocelyn Bell.
It was the first one.
The pulsars discovered by Dame Jocelyn Bell.
It was the first one. The crab pulsar was the first pulsar discovered. But you've heard that recording of the pulses, haven't you? The radio pulses.
Yeah.
But that wasn't pulsing at 30 times a second. That was a lot slower.
Let me just.
It was just a little anomaly, I thought, because I can hear that clicking of the crab pulsar.
If it was 30, you would almost. It
would be a constant, more or less a constant buzz, wouldn't it? So, to that and report back for you.
Well, what I'll do is while you do your next one, I will have a quick look myself, and we will see if we can.
Solve the mystery
on that.
But you do know what I mean, don't you? Because you can hear that sound of the crab pulsar, can't you? And it's definitely not doing, not clicking.
You can actually discern the actual clicks. Yeah, you can actually discern the.
They couldn't have done, because when you look at the and I can also see the pen trace on the paper of those pulses. And they weren't 30 times a second. So that radio signal from the pulsar is not. Have a look anyway. See what you can find out. It was just
because
something
they only were able to discern it as a pulsar by speeding up the trace time.
Yes, that's right.
So then they could actually see that it was. But, I would just endeavour to try and find out.
Moving on. This is incredibly related because N is for nova. Now, Daz mentioned the Chandrasekhar limit a little while ago. And this is part of this. So let's just explain. You often hear people use the term supernova and nova interchangeably, but that's not correct because they are two very different astronomical phenomena. A nova happens in a system where you've got a white dwarf star that is the remnant of a sun-like star. It's the sun-like star. It's the fate of our sun to end up a white dwarf star after it's been through its red giant phase. And you have a binary system where you have a white dwarf that is orbiting a much younger star that is currently going through its red giant phase, this bloated enormous star like Betelgeuse in Orion that was in the news a little while ago because of its dimming. Anyway, So go because it's dimming. Anyway, so because the white dwarf is on quite an elliptical orbit around its companion star, regularly it passes quite close to that star. And because of the immense gravity material of its companion onto its surface. Now, this repeats until the mass of the white dwarf has increased to 1.4 times the mass of our sun. This is known as the Chandrasekhar limit, 1.4 times the mass of our sun. And at that point, the dwarf has piled up to be so dense that nuclear fusion process starts. And there's a runaway nuclear explosion over the whole of the surface of the white dwarf. Massive explosion. And this is what is known as a nova. It comes from the Latin nova, meaning we're looking at a new star in the sky, where in fact it was a star that had hitherto been invisible to them. Now, the thing about this is that this process will continue. And, you know, both Daz and I remember, I'm sure, you know, quite a few novae that we've seen over the years. I remember quite a few novae that we've seen over the years. I remember the famous one in Cygnus in 1975 that was incredibly bright. And that was a white dwarf going up in a nova explosion. And so you have very rapid brightening of the star and followed by quite a long usually tail off, and then it just fades away and then becomes invisible again. But these nuclear explosions do not destroy the white dwarf. They're on its surface, they don't blow apart the white dwarf, and so they repeat. So the white dwarf again starts nudging. So the white dwarf again starts nudging in its elliptical orbit close to the parent star or the companion star, stripping material off it, and then doing the same thing on its next orbit until again it reaches the Chandrasekhar limit, and the nova happens again. Although it has to be said there are exceptions to this. We know of quite a few where the white dwarf may have been destroyed in the nova, but we've seen several novae that do repeat, that periodically brighten immensely. I mean, the one I remember in Cygnus in 1975, time ago now, so I may be remembering this wrong. I think it was actually the second brightest star in Cygnus at its peak. So that was a very bright nova. But, you know, this is a normal occurrence when you have a white dwarf orbiting a companion star and stripping material off it. And named after the famous, and he came up with the maths behind this that said, you know, once white dwarfs do reach this certain mass by stripping material off a companion star, they will explode. And there we are. So there you are, Daz. That's N for nova. Not much more to say. We never know when they're going to happen. Of course, that's the other thing we should say. Yeah. In fact, there was one quite recently, wasn't there? That everybody was excited about.
Yeah, and it lasted for quite a long time, and it was strange enough that it dimmed and then it brightened again. So
yeah, that's right.
And of course, you also get your repeating novas.
Yes, indeed.
Where again, it's a white dwarf involved novas.
Yes, indeed.
Where again, it's a white dwarf involved feeding off of another star, and they're sometimes called zombie stars. So people like to give them these silly names.
I think it's quite apt because they appear dead and then they come to life again. They appear dead and then they come to life again.
Then it comes to life again, and then it'll do it again and go off in a big flash. But it doesn't destroy itself. So they sort of like pulsate, but it's over quite a long period, sort of thing. Right. And then of course you've got the stars that do the same but don't actually. And I call those vampire stars, right. And they usually referred to as blue stragglers in
that's right.
Globular clusters.
Yes,
and there is a paper just come out that they've now found loads of young appearance stars, which are burning hydrogen.
Right,
in some way. I haven't read the full.
That's strange, isn't it? Of a young white dwarf burning hydrogen.
Yes, exactly. It's got a hydrogen shell or something around it.
Oh,
and they're still,
interesting.
So they're still looking brighter than what they should do. I haven't, like I said, I haven't read the full thing. I only picked it up yesterday.
Oh, I don't.
Checking on the crab pulsar, and it does seem to be 30 times a second. So that's from a couple of sources. So other sources in Wikipedia. So yeah.
Not to worry. I'll see if I can find anything. It's not important.
Yeah, it's just you don't know where they're getting their crab pulsar.
I mean, one has to assume that you can
discern it.
You can discern the individual pulses, and they're definitely not 30 of them a second. So
yeah, unless they like what we've listened to has been slowed down. I don't.
Yeah,
know.
maybe. But it will remain a mystery until we can find that one out.
So
okay, well, that's about it from myself. Tackling the rather circular puzzles of the letter O.
Yeah, no spiky bits on this one.
No spiky bits on this one. So we will be thrusting ourselves with gay abandon through the letter O next week. And we will look forward to your company then if you can make it. Anyway.
Stay safe. Yeah, take care. And we'll see you again for the letter O. Look forward to it.
We'll see you for the letter O next week. All the best to you all. Bye-bye.